start things off, if you're already experienced with multi-threading and what it's used for and when, go ahead and skip forward to the code part of things, or you can take a look down in the description to get a link to the GitHub where the code is posted. If you are not familiar with multi-threading, I'm going to be talking you through some of the theory first, and then I'll show you a couple of examples. So let's get started. I have a picture here. I know it's my terrible drawing, but I tried. Okay, I've got 3 cookies. Now I want you to imagine these 3 cookies are a task that we want to complete in our program. We want somebody to eat these 3 cookies. And it just so happens that we have 3 workers. So we got worker number 1 right over here. Okay, and these are like chocolate chip cookies. These guys like to eat, so I know the cookie's the size of their body, but they're going to come up here and they're all going to eat 1 cookie each. Okay. They will finish this process 3 times as fast as if you had just 1 person eating all 3 cookies. I don't know why I put that line there. So if we had 1 person try to eat all 3, it would take 3 times as long as if we had 3 people eat 1 each. That's the idea behind multi-threading. So multi-threading is great when you're able to split up your task into smaller parts. As you see here, we've got 1 part there, 1 part there, and 1 part there. They're all independent of each other, and so you can run each task separately. Now things would change a little bit if instead of having 3 cookies, we had 1 giant cookie. In this case, even if we had 3 workers, these people would not want to eat the cookie at the same time. Instead, they would line up. The first worker would eat his share, then he would leave. The second worker would eat his share, and then he would leave. And then the third worker would eat his share, and then he would leave. When you multi-thread a program like this, where all 3 workers are working on the same task, it can actually slow down your program. So that's something that you want to be aware of. Okay? When you multi-thread a program like this, where your task has been broken up into pieces, it significantly speeds up your program. So again, something to be aware of. Now 3 is a good number to keep in mind because many computers have up to 4 threads. And if they have up to 4 threads, and then we account for the fact that maybe 1 thread is already being used up as the main thread, then we really should have another 3 threads for our extra processes to use. Some computers can go up to as high as 24 threads, 36 threads, or 48 threads, like they have really high amounts. Those are super expensive and most people don't have those. So when you're designing your programs, keep that in mind. You want to build for maybe 3 or 4 threads if you're multi-threading an application, and you'll still get some really nice results. Okay, now let's take a look at the code. So we have our theory in place. I want to show you first what not to do. So if you want to skip this part, feel free to go ahead. This would be the shared cookie, where it's 1 giant cookie and all 3 workers are working on the same thing. Now I've got a lot of lines, and I want to focus your attention on 1 part at a time. So let's explain what's present and what we'll be using right now. In this program, we are using the stopwatch class. The stopwatch class will help us track how long it takes to finish each process. It's important to use something in your program to track time because many processes can finish rather quickly. So what we've done with the stopwatch class is we've created a static stopwatch that we can access from any other class. After we create the static stopwatch, we're going to start it in the main function. You want to start it just before you begin the actual task. So in this case, I've started the stopwatch and then I get into my task. If you want to know how many threads are on the device, you can access the environment.processorCount property. This will give you the number of logical processors available on the device. So the processor count is essentially the core count times the number of threads per core. So this is the number of simultaneous threads that you can use, essentially. And so you'll want to get this value. You can loop through creating threads using that thread count, and then you may want to subtract 1. I haven't tested it extensively, but I'm just subtracting 1 to account for the fact that maybe one thread gets used up by main. I'm not sure, it might make a difference. Now, I'll get into this line in just a moment, but let's just say we've repeated this process. In my case, I have 24 processors, so we would repeat this 23 times. What does the process look like? Well, I've got a separate class called myObject, and on that class, there's my own method. So my own method is what is happening 23 times. Since I've created threads, these happen simultaneously at the same time. I've created a variable to keep track of my environment processor count. I did this because at first, when I ran this method, I was confused. I thought my computer crashed. It didn't crash, it was just going very slowly. All I'm doing for the task is counting up to, what does that look like? 1 billion. I'm counting up to 1 billion. So I'm just looping through 1 billion times, adding to an int. You'll notice the int I'm adding to is a static variable. So this is something I named shared int to remind myself that this is a static variable shared among all the threads. This is what you do not want to ever do. You don't want your threads to be working with the same data at the same time. Since this is a shared int and all threads are working with the same static variable, it's going to significantly slow down the process. At the end of each task completion, every time one thread finishes the task, I write a line to let myself know that the task has been completed, and I increase a static variable by 1. This will help me keep track of how many threads have finished the job. And then once all of the jobs have been finished, I stop my stopwatch, which is again a static stopwatch, and I can keep track of my time and format it nicely. So if I was to run this at 1 billion, it would take a very, very long time. So I'm going to take off a couple of zeros and hit play. So my threads start and my threads finish, and it took me a little over 1 second. You could imagine if I was going up to 1 billion, it would take up to 100 seconds. Well, I actually ran it going up to 1 billion, and it took 86 seconds. Quite a long time. The same process, if I ran it up to 1 billion, and I did not use threads. So I'm going to go ahead and take away my threads here. Well, it's certainly not, I gotta change one more thing. So, I want this to go up to 1 billion, and I want it to do this 23 times. Am I doing this right? Mod my own method. Okay, yeah, so it's working now. We're doing it 23 times. It's taken a while. It's basically repeating itself as if we were not multi-threading. We're just doing the task 23 times. So as you can see, it's taken a while. This is not a quick process, but we're definitely going to finish before we get to 100 seconds. Okay, it took us about 31 seconds. This is an example of a case where multi-threading would have slowed us down substantially. We don't want to ever multi-thread while we're working on the same variable. So keep that in mind. If you have a data set, you have to split it up into tasks before you feed it into multi-threading. Okay, so now we're going to get rid of the shared int, and I'll show you how to do this a little bit more efficiently. So at the top of our method, let's create an int and start it from 0. And for the task, let's just make this a++. So the difference here is we're no longer working with the static shared int. And And just for consistency, we'll go ahead and try it out. You can skip forward about 30 seconds and the job should be done. We're almost there. Okay, so it took about 31 seconds again. Let's multi-thread it this time. So this time I'm going to use as many threads as I have available on my device. And we'll press play. It starts and it finishes. It takes about 2.38 seconds. I'm going to zoom in real quick. 2.38 seconds. Much, much faster when it's multi-threaded. If we were to calculate that, we just went from 31 to 2.38 seconds. That's 13 times as fast. We could finish 13 times as much work. Keep in mind, I am using 23 threads, so we do lose some efficiency here. It's not 100% efficient, but 13 times as fast, that's much better than 1 times as fast. If I wanted to use only 3 threads, then what I could do is I could, maybe I'll do just 3 here, and then I'll just take this task and do it 8 times. And then I'll just check for 3. We'll time it at 3 threads. So it's a 31-second task. We're doing 3 threads. We'll see how long it takes. Okay, it took about 10.89 seconds. So we'll do some calculations really quick. 31 divided by 10.89. And this is much closer to 3 threads. So the fewer threads you use, the more efficient it's going to be at splitting up the task. If you use more threads, it loses some efficiency, but you still will see gains in performance. So obviously, if you have 23 threads, you're going to run faster than if you only have like 4 threads or 3 threads. Okay, but no matter what, we saw 31 seconds down to 10.89 seconds. That's a big deal. So keep that in mind. If you split up your task, it's effective. If you don't split up your task, it's not. So now let's look at the code and how you can modify this in a couple of different ways. Because sometimes you'll want your task to have some information that's getting fed into it and then some passed into it, and sometimes you won't. So what do I have here for my little test program? I'm going to break it up into all the parts. I have a class. This class contains the information that I'm going to use for my multi-threaded process. Now, multi-threading is not something that you just use as a blanket statement for your program. Multi-threading is something you do to the most computationally intensive parts. So one of your methods you can turn into a multi-threaded method. Okay, you don't just say, hey, my program is multi-threaded. It's the actual method that you want to turn into a multi-threaded method. So in this case, you'll notice my constructor has a parameter. Okay, if you want to pass information into a multi-threaded process, you have to use a class designed for that multi-threaded process, and it has to have a constructor with a parameter. So what will happen is if I go to my object, I have it right up here, then my constructor will take that parameter and it'll pass it into a variable. I now have access to that variable for my process. So that's how you pass information into a multi-threaded process. You are not allowed to have parameters here in the method. Okay, you can't pass parameters into the method. But what you can have is a class that contains other variables, and your class can have a constructor with a parameter. So that's the workaround for multi-threading with parameters, just so you know. So at that point, I could then use this index variable in my method if I wanted to. Okay, next thing is once you've instantiated your class, then you want to create a thread. So to create a thread is real simple. You have to have the using system.threading line, and then you'll create a thread type variable, and in the parameter you put the method. Now if your method is on a separate class, put the class name dot method. So we've created this class variable dot my own method. Notice how there's no parentheses at the end. Once you establish the thread, you want to do thread dot start. This will start the task and the thread will kill itself when it's finished. So if I loop it, I can tell the program how many threads to activate. And if you want to get the amount of threads available on the device, you can do environment.processor count, and then you can either run tests or subtract 1 or subtract half. I don't know, it's up to you how you want to decide, but you can figure out how many processors are available for your multi-threading calculations. In the actual process, one thing that's important to note is since these are running asynchronously, after you start all your threads, what's to say your program won't try to do something else? If I had the stopwatch class, right, then I could do stopwatch.stop and do all these things right here. And this would be problematic because check out what happens. My stopwatch is going to stop almost immediately and we get a time of 0. Okay, that's because I started my threads and then the code, it ran down over here and it finished itself. Okay, so I went through my loop, I started my threads, and it immediately went and stopped the stopwatch. So that doesn't tell me how long the process took. In fact, it stopped the stopwatch and then later on the process actually finished itself and then it tried to stop the stopwatch again. So keep that in mind. When you start a thread, your code will continue. So what can you do to prevent your code from continuing? Well, you can use something like this. You can do thread.join. Join will stop any further code in the main thread from happening until the thread's job is done. However, if I was to run the program like this, that would be problematic because now, and I'll show you while this is happening, as soon as the first task finishes itself, it'll take, I don't know what, 10 seconds? Is that what it took? So it finished the first task and then the next thread starts. That's a problem. If you're multi-threading, you don't want to join inside of your loop. You might want to join outside of a loop. If that's the case, then you need to have a collection. So you can create a list of threads using system.collections.generic. And then within your loop where you're multi-threading, you can add your threads to the list. So I can do threads.add and then the thread that I just created. And then at the very end of it, I can say something like threads and then threads.size, I think it's, no, maybe count, -1 dot join. I could do something like that. So that would join the last thread with the main thread, and it'll prevent me from stopping my stopwatch. If I do it this way, all my threads should run simultaneously and it should take about 10 seconds. Notice how my stopwatch, it went off right here. Okay. Turns out my last thread actually finished first, interesting, but the next threads were almost at the exact same time. So again, if you do something like this, that's not always guaranteed to continue your code at the right moment. What you may want to do is maybe join. I guess join is just. I wonder what would happen if you tried to join the other ones, but we'll save that for another video. But join will prevent your later code from running until the thread itself is finished. All right, is there anything that I forgot to explain? This is just a stopwatch class. You can get that from Microsoft documentation. I think that was about it. Yeah, so hopefully this was helpful and you gained something from it. Multi-threading will significantly speed up intense calculations in your program. Don't use it for something small. It's not worth the effort to multi-thread something small. And again, don't use it if they're all trying to bite into the same cookie. If you've got a static variable and every thread is accessing the same variable, it will slow your program down. So to recap, here are some of the numbers. So I'm going to go ahead and type it all in a comment so Visual Studio doesn't get mad at me. To recap, multi-threaded with 23 threads, it took about 2.38 seconds. You can go back and check. My memory's okay. I think it was about 2.38 seconds. Multi-threaded with 3 threads took about 10.89 seconds, something like that. And then when we did single thread, it took about, I want to say 31 seconds. And then when we did multi-threaded using a static variable, this is the wrong way. This took 86 seconds. Okay, so multi-threading can slow your process down if you do it the wrong way, or it can significantly speed up your process if you do it the right way. So hopefully this was helpful to you, and I can't wait to try out all the things that you make with multi-threading. Hopefully you make some really good games, and then I can play them and have a good time. See you guys in the next video.